Good morning. Once again, thank you for joining to this webinar. My name is Sadair, an FAE for Ion Associates. And today, along with my teammates, Marvin Govindan and Raul Dominguez, are going to talk about audio solutions. For today's agenda, we are going to talk about a little bit of evolution of audio components. Then we'll give a brief example of the components contained into an audio solution or system. And of course, on today's requirements, audio components require to be more advanced, not just a converter between audio and electrical signals, but to be able to do more than that. So for this reason, we are going to talk about the trends in audio processing, where it is cloud or edge processing. Of course, we are planning to provide some examples of applications that we have identified for the development of new products. And we're also be including some examples of the technology that we can provide with the principles that we represent. So as we can see on this slide, we've seen through many years a constant evolution of the audio components. Talking about the first component, the gramophone that was invented in 1876, and the evolution through the records, then the tapes, moving into CDs, MP3s, and today's streaming, audio streaming, and of course, the processing that we can find in the devices that we use in our common life. But first, maybe you already have seen all these devices, or you might think already on the components that are implemented or included in any of the audio components that we were using. But we want to cover and talk about some of these components that are already in the audio components. We can start also from the input, the microphone, moving to the processing, and we might go up to the output with the speakers. For the speakers, we already know this, but this is just a converter between electrical signal to audio or acoustical energy. Normally, when we talk about the speakers for the consumer, for a person to use, we may think about working in a frequency between 20 hertz and up to 20 kilohertz. But also, when we look more deep into the devices that provide or that implement a speaker, we might find that there's more than one speaker. Yes, one single speaker could be able to provide could be able to work and provide like the complete frequencies for an audio, for a music. But if we take a look a little bit more deeper into that, we might find out that this single speaker is not able to provide a full quality signal or sound for all the frequency. This is the reason we are finding more than one speaker. Each of these ones a specific design to work in a specific frequency, providing a better experience, audio experience to the user. For example, for lower frequencies or low frequencies, we will see the woofer and the subwoofers, and for higher frequency, we have the tweeter and the super tweeter. Also, as the technology keeps improving and the devices are getting smaller and smaller, also the devices, the electronic components require to be smaller without sacrificing performance. For this purpose, we are finding the micro speakers commonly used in consumer devices, like smartphones, earbuds. The use of these micro speakers definitely, or the purpose for this one is to provide good audio experience, good frequency response. Also, for small devices, we have the balanced armature drivers that are provided, in this case, with one of our first manufacturers, Knowles. The balanced armature drivers are meant, as we can see, for small devices like earbuds, for example. These devices were originally developed for hearing aid applications, but as the consumer products start evolving, we are now seeing these devices implemented in consumer components. How they work? We are seeing this small or tiny reed that is located between two magnets. As the sonic or the sound is transferred into and is changed into a mechanical move. This mechanical move of the tiny reed between the magnets is the one that creates the sound. That, in conjunction with a diaphragm, we are generating the sound. The use for these armature drivers, or these armature drivers, can be used in two different configurations. We have the multiple drivers or the hybrid systems. For multiple drivers, which is the first one, we will find different BAs or balanced armature designed with to work in specific frequencies in order, as we mentioned before, to provide a good sound response. Also, we can use with other normal dynamic drivers, speakers like this one, the one that we are seeing here, which is one of the most common examples or application that is being used. In this case, the dynamic speaker is used for lower frequencies, and the balanced armature driver is for the higher frequencies. The good thing about this application is that with this system or this configuration, we are providing a better audio quality for the consumer user. Another component inside an audio device is the microphones. We will find in the industry many technologies, many configurations. Just the basic right now is how we receive the sound. As you know, as we might remember from the basic, we have three different microphones depending on where they receive the sound. For cardioid or directional microphone, receiving the signal from just one direction. We also have omnidirectional that are able to receive sound from all the directions, and of course, bidirectional. For the microphones, we can help with the manufacturer notes. We are going to share this presentation. So in this presentation, you will find specific links for some examples. In some cases, for the products. In some other cases, we are giving you links for some application notes that you can read for getting a better lecture or more information about all this webinar. Getting back to notes, we have analog and digital microphones, as we can see, with different shape and sizes. Some of them including or helping in power consumption, like sleep, low power, and standard mode function. Another thing that we are able to provide with Knowles is the sub-miniature microphones, similar to the balanced armature drivers. Also helping in noise canceling and these can be omnidirectional and unidirectional. Getting more, talking more about the other products that we can offer, in this case, with another one of our manufacturers, Cirrus Logic, we will find digital to analog converters and analog to digital converter, which is really basic. So the analog, as we remember, converts an analog signal into a digital, and vice versa with the digital to analog. We have many products that we can help you in which we can help you with Cirrus Logic. We are giving you the links for this one. Also we will find the audio amplifiers. There's many different configuration or different audio technologies, amplifier technologies. In this case, for the purpose of this webinar, I'm going to talk about just a few of them. First, we have the Class A amplifier, which provides high fidelity, but honestly, the efficiency is not the best. Why is this? They have a transistor working inside that is the one that helps us do the amplification. The bad thing about this transistor is that it's always on. No matter if there is sound, or maybe if it's no sound in the input, it is always on. So that is the reason is not very efficient. Yes, when there is presence of sound, yeah, it is transferred into the speaker, but when it's not, it is transferred into heat. Then we have the Class V amplifiers, which include two transistors. One for the positive signal, and the other one, a second transistor to amplify the negative signal. We are getting more efficient, but the fidelity is not the best. We have also the Class AV amplifiers, which is the same, has a similar configuration that the Class V, meaning the push-pull configuration, the transistors. The difference is that there is a delay. So in order to turn on and off really quick the transistor, there is a delay in the on and the off conditions. So we can have a little bit better efficiency. And finally, for this case, the Class D, which, as we can see, have really good efficiency, up almost 90% of efficiency, and include other components like maybe a pulse width modulation, PWM, and some other circuits. These are the ones that we can provide or we can help you with Cirrus Logic. With Cirrus Logic, also we have, and inside an audio component, we will find the codecs, which are more integrated devices, include analog to digital, digital to analog converters, also running with digital commands and communicating with external devices like with digital buses like I2S, SPI, I2C. We will see with Cirrus Logic that we have a lot of different codecs that you can use depending on your requirements. And finally, the processor. A processor is once again a more integrated device that might include a codec, a converter, an amplifier in some cases, but providing more than that, meaning that we can have multiple channel selection, balance control, voice canceling, which would be the main purpose for a processor, to be able to process some of the signals inside the devices and releasing the main processor to do this specific task. An example of the solution that we can provide with nodes is the IA Sonic, which is normally used for edge processing. And we are covering this in the next slides, but for edge processing, we mean that we can do most of the processing inside our component without requiring a cloud or external processing devices. In this case, we can do voice activation. We will see during the several applications that we will cover that voice activation is one of the main advantages or the main things that we can implement into these new components. The elimination of the push to talk just by saying the command, the right word, and in order for the device to wake up the entire system. Some of the examples are definitely for low power applications. We can use this maybe in an earbud on a headset that can be most of the time on sleep mode, and without the need to push a button, we just need to say the right command, and the devices, the processor will detect that phrase and wake up the entire system. Also for proximity, if we use this processor in conjunction with a speaker, ultrasonic speaker and microphone, we can detect, we can be able to detect the distance between the person and another external object, eliminating the need of an infrared sensor, which we know has some limitations, sometimes in distance or sensitivity. Also, we can use that as a hub, meaning that we can use devices. For example, we can use Alexa or our cell phone, or maybe just a consumer device that we made, the thermostat, to do more than that. Not just to control for example, for the thermostat, not only to control the temperature inside the room, but also to be constantly receiving the audio and processing the audio signals that we are capturing. In order to do more than that, detect, for example, if I am getting sick just by the change in my voice, or if a baby is crying. Also, in conjunction or complementing this, we have another application for security systems. For security systems, we can use also these devices or a security camera to detect maybe if some specific noise are being happening around the environment, and trigger some alarms. And once again, finally, for the earbuds. The earbuds can be on sleep mode or low power consumption, and just wake up by some specific commands. When we talk about, we've been talking about the difference, or we might identify different trends in the audio solutions. We are going to focus on the processing. So for the processing, we are seeing this more and more, whether it is in our devices, personal devices, or in devices like that work with cloud technologies like Alexa. So we will see devices that can do the processing inside, without inside this component, without the need of a wireless or a Wi-Fi connection, or which are and these devices are called edge processing or edge processing devices. And also, if we need, we require, or we wanted to work with Alexa, with Siri, we will find the cloud processing. Also, we might find an hybrid processing that can do some internal processing, and for some more, or for more advanced requirements, we can use the cloud. But we've been talking about just the components, but we need to remember that for all of these applications, we require a software. In this case, one of our partners can help you to facilitate the time to market into the development of the software. With Sensory, we can help you, where it is maybe just the software for your smartphone, or the software for your processor in your device, in your design, that can help you with developing the algorithm for detection of some specific phrases, some specific words. It can work on edge or cloud with the support of edge or cloud processing. For edge processing, as I said before, we can use it for more than just the simple task for the test for the thermostat, for example. Yes, we can use the thermostat to send just a command: turn on the heat, turn down the heat, turn on the temperature. Or also it can be used for other than that. Maybe detection of specific noises and trigger some alarms. A baby crying, a glass breaking, a door opening, and send the alarm to the specific authorities or the parents. In this case, once again, we have a solution with nodes. We have a first processor that can help you depending on your application. The very simple is what we call a smart microphone, which is a microphone with a smart processor with the capability of doing this simple task like wake up word. The other thing to consider is the cloud processing. In this case, we are getting more familiar every day with this Alexa, Google Assistant, Siri, which help us with more advanced processing in the cases as long as we have internet connection. For interacting or start developing some products with this one, we can work with nodes from scratch, for a design from scratch. We have some AVKs that are ready to interact with Alexa, providing the basic for you to start working into your implementing this cloud processing into your product, where it is for an earbuds, a laptop, a speaker. This evolution kit can help you into that. Also, and this is just for once again, designs from scratch, if you want to design your own products from zero. But we will find some cases when maybe the company, the designer, doesn't want to do something from zero. Maybe they just want to use a module that is already been developing and is ready for production. In this case, with RX Labs, RX Laboratories, we have some ready production models. We have two solutions that you can use for just plug and play into, or put it inside your board. The first one is a front end, which has the processor, the audio processor, and there is another one, the every word that implements a wireless connection, an external processor, not only the model. This one has embedded this front-end model in this part, and you can use it implemented into your device. It has the amplifiers, output and input signals and connectors. And we have the AVK, which internally has this board, also has some microphones internally, boards connected to the device, and can help you to do the implementation more quickly. Some of the examples that we can use for this one is like a smart speaker or smart microphone that is connected to Alexa. So we can use it to play music, to set right command, just like the normal devices that we can find in the internet. Or also just as a smart speaker, a smart microphone, without the need of a direct connection to the cloud. The advantage for this kind of devices or this product from RX is the processing. These devices can help us to filter external noise. The device will be able to detect only our voice and filter all the external noises. Even in really noisy environments. An example, we are in the living room with the TV playing a soccer game, real high volume. I am 3-4 meters away from the speaker, and I can, even with all that inside this noisy environment, I can say the right command, Alexa, play or play music, or pause or stop the music. And even with all this noise environment, the device will be able to detect my voice only. So this is one of the advantages for all this processing. And or maybe even though I'm just in a conference room by myself, but once again, away from the speaker or the microphone, 2 or 3 meters away, I can I can speak. And on the other side, if I am maybe in a conference call, the device will be able to detect my voice and normalize the volume. On the other side, the other user won't be able to detect if I'm close to the computer or far away from the computer or the microphone. So these are one of the advantages of, once again, all the processing that we can implement not only with RX Labs, but with the other solution that we have. Of course, the solution, once again, as I said before, it can work on the cloud or an edge processing or an hybrid system. Talking about audio, I will give the word to my colleague Raul, that will talk about BLE audio.
Next, please. Hello. When we're talking of audio, one of the things that we have more present in our lives is Bluetooth. Next slide, please. So now with the new generation of BLE audio, we have more things that we can do. Before, there was just classic Bluetooth audio. Now with the release of the 5.0 and going forward to 5.1, 5.2, 5.3, we're finding more things that BLE audio supports. Some of them, for example, are the group performance. There's a new LC3 codec that has better audio quality and reduces the data rate use. So that helps us to share better quality audio using less data. Also, it's lower power consumption and shorter latency. One of the things that are especially wanted by some of the people are the multi-stream, that there are separate audio configurations depending on what is the usage. For example, if it will be for a speaker or for headphones. And there's the broadcast audio. This is called Auracast. This will help to share audio in personal environment or to broadcast at public locations. We will see in the next slide. Next, please. For example, for personal audio sharing, sometimes we see that we don't want to make noise in a certain room, for example, and people playing on video games now will benefit of both hearing what is happening without disturbing the ambience. But where we find more usage is now for public venues. We know that in several places you can hear well, or there's a lot of noise. For example, in gyms, not everyone likes or the music or the news. Each people is different, so they can adjust the screens and just the ones to want to hear the what is shown in the screen can synchronize and hear that. Also, if you're talking on airports, for example, when it's very difficult to hear, you will be able to subscribe to the Bluetooth that is broadcasting, and hearing your own language. That will help because when you go to foreign languages, sometimes you can understand what they are saying. Also, for guided tours or for conferences, there are several usages for broadcast audio. Next, please. With Bluetooth, we have these modules. Some are standalone, some are host-based, where you can use and implement the Bluetooth audio. We have standalone modules. That means that they have a microcontroller inside. You can do the functioning there. It's dual core modules, and you can implement Bluetooth Low Energy, including BLA audio. And we have more powerful modules that are host-based. This means that they need a microprocessor to run the stacks. But at the same time, they are more robust, more capable. They have more capabilities to do, mostly in the Wi-Fi section. But both are working well with Bluetooth audio. Next.
Thank you, Raul. Now we want to talk about some of the applications that we might found. Some of them, you are already seeing them in the market. Maybe you are already developing some of them. But the idea is to help you with ideas to and of course, once again, the meaning for this webinar is for you to, for us to help you, try to give you some ideas and see the supplier that we can that can help us for your development. When we talk about applications, the first we will find, or the first idea is about smart life. Things that are being implemented already, whether it's in the house, whether it is in our personal devices, that now are starting to use voice control. And voice control not only by pressing the push a button and talk, but to detect where when I am talking, if I'm not, to put on low power mode, and of course to detect the external environment and filter all those signals. We will implement several of the components that we talked before: microphone, smart microphones, processors, speakers. I will share, once you receive this presentation, you will find some application notes, some links for you to review and have more ideas. For smart home, the first application that comes to my mind is a washing machine, for example, that receives specific commands to turn on, start the washing process. Also, we have the thermostat, the shades, maybe a kitchen hood, for example, that turn on just by a voice command. But we are finding some other products: the lighting, turn on the light, turn off the light, a smart camera that detects the external environment noise and triggers some alarms when those specific unwanted noises appear. And also in the TVs, and not only the TVs, the remote control. Now we know we don't need to push the buttons or push a button to talk. The remote or the TV by itself will be constantly waiting for the keyword to wake up and change the channel, lower the volume, and of course, with the use of our manufacturers, with nodes, we can help you. We have some examples of products that can help you on this. For consumer devices, we have the smartphones, we have the earbuds, we have the speakers. And also for the earbuds, or the true wireless earbuds, TWS, we have the voice wake up, noise reduction. We also are able to provide high quality audio. And one thing to consider when we are developing maybe an audio device, an earbud, a headset, is the frequency response that we might have. As I said before, for providing and detecting better audio signals, sometimes for the audio output, we require more than one speaker. The same for the microphone. Well, not the same, because we just need one microphone. But the thing is, as the technology keeps improving, also the devices has to respond like that. Normally, as we know, some of the human response in just one specific audio frequency or frequency range, but normally this range is not the best. For this purpose, NOS has been working and doing some research to try to improve some of the frequency response that we have. And they are getting into this curve that we have. Normally, the audio response gets on up to 10 kilohertz, and after that, it won't have a good high response or good quality response. What nodes have done is to improve or integrate this external or improve the audio or the frequency that we are going to be working, and in order to provide a better audio quality. Yes, definitely every person is different, so maybe this won't be able to work for everyone, but the thing is that in general, this external or this improve into the curve is giving the user a better audio experience. Also, in order to help the customers into the development, we have some design reference. In this case, the KN2, which is a design reference that the consumer, the designer, can use in order to facilitate or to reduce the time to market development. This is the second generation. We have the first one, but customer can use both, and they can just copy and paste. Use some of the product that we have, and not only the processor, the audio components, but also we can consider some other technologies like sensors. In this case, also we can help with another manufacturer like Automotive.
So whenever you will be using any audio device, most likely you will need to control it. That means you need to select things, move the touch, like buttons. But now with the reduced size and the enhanced functionality, normally we find that all of them are touch. With Azotec, we have two types of technology. One is capacitive and the other is inductive. The capacitive is the normal thing that we normally see when using a smartphone, that we can select, scroll, do several things with our fingers. And the inductive, what it does is, if we have a foil, a metal foil, the inductive will take the smallest deflection of the foil. So that allows us to do an enclosed waterproof casing that it doesn't matter if it's wet or not. You can press and it will detect if you are pressing or not. So we can find these kind of devices in the speaker systems, smart speakers, wireless, several things where you need to turn off, play, pause, synchronize. Also, you can do some rotation sliders and several things with these kind of solutions. With Hasotech, we can offer either the chips, so you can design the button sliders or what you need, the trackpads, or we can offer the complete solution along with the PCB already designed. Next, please. One of the usage is also in the hearables. We have the in-ear headphones or over-the-ear headphones, like these ones. Each one has different functionality because they need to detect in a different way. For example, as now we are seeing more and more wireless things, you want to preserve the energy, to have them with a deep sleep until they are used. So with our special ICs, we can offer in-ear detection, so they will detect when you have it in the ear. It's outside or inside, depending on the usage. And also you can see that you can have touch buttons in the normal way that you use in your cell phone. You can have a whole switch for docking when you dock your headphones to be charged. We have the inductive switch that we already talked, that is completely waterproof. And also we can have a gesture pad, so you can have a small portion when you can kind of draw up, down, left, right, tap, and it will detect, and then you can act accordingly. This works for in-ear phone and over-the-ear headphones. Both has the same type of things. On the over-the-ear, we also have a whole rotary encoder, so you can have something that rotates to control something. Next one, please. Here we see the ICs we have and what they do. For example, we have this 626, the first one that you see, that offers the capacitive interface, for example, the play buttons, and also the in-ear detection. So you have one IC that can do both. You can add an extra one that will give you the capacitive and the docking effect. So you can decide which combination to use. Maybe you can, or you want to do a simple things, you use one, or you want more complex or more functionality embedded in the device, you can use 2 or 3 of our device. Next.
Thank you. And finally, when we talk about an audio system, we can get the support or you take advantages of new technologies in the sensors. Once again, you release the main processor for some specific task and keep the device consuming lower current, lower power. In this case, we also can support your development with Bosch sensor tech, specifically talking for consumer devices with an accelerometer that can help to detect when I am moving, my head orientation, also if I am walking, running. So these moves and the in-ear detection can help also to facilitate the voice processing to the other components. Another example that sometimes we forget about is the smart cities, to do the audio monitoring, to detect the noises, to detect some specific noises and trigger some alarms to help the cameras or the speakers in the city to notify the authorities. But not only that, we can get use of the audio devices and not only implement that maybe in a camera, but some other devices or products or components that are installed within the city, like kiosk. So we can do more than that, analyze the signal, maybe identify the noise pollution, and help into do or new highways, maybe change the direction, or if the government is considering to do a highway that moves around this specific town, and they are identified that this might not device because of this noise generated, they can reroute these highways, these roadways. So once again, it's not just like the basic application that we are identifying, but more do than that. Also, in order to help into this processing, whether it's cloud or the edge, we can take advantage of some other products like AI. For this purpose, for these parts, Marvin is going to help you with the explanations.
Thank you. Yeah, so for as I mentioned, we also have computing, which could help us develop maybe our algorithm, or has it to make the inference for the algorithm that does the processing. So we have on the right-hand side here, we have a development platform which can help you to develop your algorithm, if it's to detect sound, detect patterns in sounds. We have different flavors of this tank AIoT system, lots of interfaces to help connect to your laptop and then to other devices. Within this module, we can also add in an accelerator card, as you can see here on the left-hand side. So that helps us do some high-level computing, extra fast processing of what we're trying to detect. So Alia mentioned maybe like audio detection in a smart city, could be gunshot detection, broken glass. It could be linked to a network of sensors or cameras. And we might want to do some processing on the edge, or we might want to have some of these in the cloud in a data center somewhere, some of these accelerator cards. Next, please. So yeah, we have with AI, we have different development platforms. We have gateways as well, which we can have communication modules integrated as well. We can add screens, add other sensor nodes, connect physically to the internet, or use the modules which have SIM cards inside them. And within these modules, they're expandable. We can add in accelerator cards as well if necessary. We work with partners as well. So Intel's OpenVINO toolkit is available for download, and we support that type of algorithm development with those third-party tools. Next, please. So yeah, depending on what you're looking at, I mean, usually when you're making an application, we're using accelerator cards. You want to lower the power consumption. You want to maybe reduce the data. Like maybe if you're processing data, you want to reduce it somehow, so you're not generating excessive charges, or with your carrier, or processing, minimize the processing amount that you're making. We also need to have consider encryption for sensitive data, especially if it's a smart city, authentication, key exchanges, and apart from compressing and decompressing data. Next, please. And back over to my colleagues. Thank you.
Thank you, Marvin. Another application is the audio is for automotive, for detecting again the specific commands without touching any external button. For the products that we can offer in the automotive market, we have with Cirrus Logic audio amplifiers, drivers, volume control, voice processors. With Knowles, we have microphones specific developed for this market. And not only that, also we already covered the main products that can be implemented into an audio device, but we might find some other technology that can help you into your product. For this kind of external or additional solutions, we have, in this case, with the support of Raul.
Hi. For example, when we're talking about outdoor speakers and wireless speakers, we need rechargeable batteries. So we have this brand, TWS, that offer lithium-ion batteries, custom-made. We have been very successful with some kind of these devices, overall for outdoor devices, that offers some offers just the speaker, and some is also a charging station. Here we are seeing a charging station with speakers embedded. Next.
Also, if we are developing maybe another kind of products, not only the amplifier, the chip by itself, but we want to do some discrete or more higher products. We have another one of our partners, GAN Systems, that can help into the development or high power amplifiers. They offer GAN technology or GAN FETs, and we have some specific design reference for these applications. Also, we should not forget about the connector. Most of the products that are used, that we are going to develop, will require a connector, where it is for connecting maybe doing some internal connection, board to board, wire to board, or to the external world, like USB for the charging. We have products that can help you into this development. Also, another one of the principles or manufacturers that we can help you with is for little fuse, for not only for the power devices, but for the protection. And if you want to implement a mechanical switch, also we have CNK, which is now part of little fuse, with some products that can help you also for your application. And that would be all. That would be all for today's webinar. I know there's plenty of more information that you can find on the internet. Also, the idea for this webinar, once again, is to give you a brief example of what we can help you. Because for every supplier, we will have more information for you to share, technical information for us to share with you. And the idea is for you to see what we can do. And maybe in the future, in the near future, identify more technologies, or some of the technologies that maybe you are already looking for. And I think that's all. I'm not sure we have any questions. Once again, in the Zoom application, there's a part for Q&A. If you have any question, you can do that right now. Or if you want to send the question later, you can send us an email to our colleagues, the account managers that you already know, and they can work. We work with them. In this case, we support the technical side along with the partners that we represent. So I'm not sure you have any question. If not, we appreciate the time for you during this webinar. We are going to send you this presentation, and we are going to upload the video to our channels for you to see it later, maybe. So that will be all for today. Thank you for joining, and have a good day.